not going to be difficult. Let me just type it out. Okay, I'll just whatever terms I cannot type, I'll just write it later. So maybe if we are required, sometimes a function may not be analytic, and we still need to require to expand it. Okay, how will we expand it without using the Taylor series idea? We can do it. Okay, so if we are required to expand, okay, fz, okay, about the point where the function fz, okay, is not analytic, let's say, then it can be expanded by Laurents series, okay, by. So there we are actually going to use the Laurents series, and that is how it is different from Taylor expansion. Okay, there is a statement to it, but when you do the sum, you'll see that it's very simple. So I'm just going to use one or two sums. I'll give you one, others you can easily do it. If fz is, let's say, is analytic on, let's say, two circles, C1 and C2. There are two contours on which it is analytic, okay, and annular region. So I'll just draw the diagram, I think, and that will be easy. Annular region R, okay, bounded by concentric circles. One is subscript. Okay? I cannot really type subscript in this app. So I'm just using it. And radii R1 and let me write in small r. Okay. And of course, we might have a condition where we need to know which one is inside and which one is outside. So R1 is less than R2. Okay. And with center at A, then you can actually have a series, okay, and that will actually given by Laurents series, and that series, maybe we can just write it down. Series I cannot type, so we can write it. So the series would be something like this: fz is equal to a naught, whatever is the point we're talking about here, plus a1 z minus a, okay, plus a2 z minus a whole square, and so on. Okay, this will be the series. That means here you don't really need to consider, you have to just expand the series. That's it. Okay, that's what is more important. So if I just draw a circle, I can draw it properly here. Let me just try. And we're talking about an annular region. In some of the competitive exam papers, I have seen this. They do give the image, okay, and you have to analyze from the image and actually use the series to actually do the expansion. So it's important that we actually have a proper understanding of the image that we're talking about. These are the two radii, okay, and let me take a different color here so that I can edit it. So this is R, let's say R2. Let's just be consistent with the statement here. R2 is less than R1. So this is R2, and let's say this is R1. Okay, and this is the contour that we are talking about. Let's say this is your C1, okay, and the other one is C2. So this, maybe we can take it up to it. So it is a continuous contour. It's not that there will be some kind of discontinuity. There will be continuity. So that's very important when we are actually using or expanding these, using series and all. You can also find out the nth term. We won't be doing any example in the nth term, but that is a statement which is given. An is equal to 1 divided by 2 pi I, okay, integration. Let me take another function w, okay, maybe it's a combination of u's, okay. Now w minus a to the power n plus 1 Even we can find out what is the nth term of the series if it is not analytic about a point. Okay, that's the entire idea. That's it. Okay, nothing else we need to understand here. So that's your Laurents series. Okay, that's the Laurents series. So this is basically the statement that we have in Laurents series. What I'm going to do now is I'm just going to take an example, and you're going to see that you have to just consider the region, take it correctly, and then just analyze it. That's it. Okay, that's the the simplest thing about doing Laurents series. So let me just take one example, and you will understand. You really won't be mentioned whether you are going to use Laurents series or not, or you need to use the Laurents series or not. You will understand it from the question itself. Okay, so maybe the question is expand series, okay, and this is fz, okay, is equal to 1 divided by z square minus 3z. Okay, so if you just take it that way, what you're going to see is some regions will be given and supposed to expand the series. Okay, the regions for expansion of the series will be given, and that will be the question, and that is something which you have to understand. So the regions are, let me give you the question completely. This z will actually lie between 1 and 0. This is just a trick that you need to know. That's it. Nothing else in this particular thing. And then in this region also have to expand the series, let's say 2 and 1. Okay? And this one example should be more than enough to understand what it is. Greater than 2, and one more might be 0. It is z plus 1 and 0 and 2. Lies between 0 and 2. Okay. So let's just try to solve this. So it is 1 divided by z square minus 3z plus 2z. So what you can do is you can do middle term factorization for this and actually find out. So we are going to do middle term factorization. I think we can do it, right? Is minus 2z minus z, or z minus z minus 2z you can do. Okay, and then you can actually expand it, take common in it. So if you just do it this way, z square minus z minus 2z plus 2, right? You can expand it in this way, and then you can take common z both the cases, and it should give you z minus 1, z minus 2. So we have expanded this. This is something which is expected. And then if I just do partial fraction, okay, I think we just now did this similar sum. Okay, so if you just do the partial fraction, you can just take it to the minus of 1 divided by z minus 1. Okay, plus, okay, whatever the other one, d would be nothing but z minus 2 can be made 2, that is equal to 2 minus 1, which is 1. Okay, so maybe into this to be 1 divided by z minus 2. Just check it. I've just done it directly. I don't know if I've done it correctly. Let me check it here. It looks okay to me.
Correct, sir.
Correct, right? We've done it, I think, in the last previous day. I think it has seen. Okay, I've taken this example itself. Check. Yeah, z minus 1, z minus 2. Okay, this is the same. That's correct. Okay, so if we do it, this is something which we already have now. We have already expanded it. Now we are just going to expand it. That's it. If you look to the first problem, you have got z. If you look into the first problem, this z that we have is actually lying between 0 and 1. Now look into the singular points here. Z is equal to 1 is a singular point here, this particular case. So that means this is not analytic, but I have to expand it. So what do I do? It's very simple. I first take up this, let's say fz is equal to 1 divided by 1 minus z, right? So we take this 1 minus x, 1 plus x inverse, and 1 minus x inverse. Those are the expansions that we know. And we're going to take it in that form, 1 minus z plus, okay, this is 1 minus, I will take minus here. So this would be minus 1 divided by 2 minus z. Okay, and then what we can do is we can take the 2 out, right? So I will take this as 1 and this would be z divided by 2 and this is a 2 here. So this way I can actually expand it, okay, and if you just consider this range, it is less than 1, okay, within this range. So it is not at equal to 1. So that means I can do a simple expansion of this. So that means it will be in analytic at z is equal to 1 because it's within this range, okay. So z minus 1 minus of half and then 1
So
minus
for
z
this
divided
condition,
by.
it's analytic now.
Yeah, yeah, yeah.
So for the first condition, which is given as 0 less than mod z
Mm-hmm.
less than 1, for this
Yeah.
condition, getting the function as an analytic one.
Uh-huh. We
Because
can expand it. We can expand it this way, right? Because z is less than 1, right? Can you check this? If you look here, this z is less than 1, right? It will be not analytic at z is equal to 1, correct?
yes,
So that means I can just simply expand it in this way, and then you can just use this 1 plus x 1 plus x expansion, simplify it, and you'll get the answer. Okay. Let me just take the second one and try to explain it now. Okay. Let me just show you all four. Okay, this is simple now. See, this is done. Now I can just expand it and find out whatever is the answer. Okay, let's try the next one. Okay, in the next one we have to understand few things and then only we will proceed with the expansion. So z, this is less than 2. Here you observe two things. First thing, 1 is less than modulus of z. What does it imply? It implies that 1 divided by modulus of z would be less than 1. Because if you're looking into the circle, okay, and we are saying, let's say the radius is 1, okay, we have to basically, find out, arrange the values in such a way so that it is less than 1. So I will see in this particular case where z lies between 1 and 2, 1 by modulus of z would be less than 1. Okay, let me just do it and I think it will be a bit more clear. And here what we have is modulus of z is less than 2. That means modulus of z divided by 2 is less than 1. We are just considering a circle of radius 1. Okay, if we do it that way, and if you look into the function now, which is fz is equal to minus 1 divided by, write down this again, z minus 1 plus 2 divided by z minus 2. Now in this particular case, 1 by z is less than 1. We have got z here and not 1 by z. Okay, so I have to take this value as less than 1. How? So what I'll do is I will just take minus, I will take 1 by z, I'll take the z common. That means I am left out with 1 minus 1 divided by z. And when you look into books and all, they will see that they will do it directly. Okay, they will probably won't explain it this part. Okay, but this is very important because we are considering a circle of radius 1 here. Okay, and when we do that, okay, when we basically do that, because region of convergence is at z is equal to 1, so radius is 1. So when we do that, we have to write down the function in such a way that it is defined within that particular circle, so this particular part. So 1 minus 1 divided by z. Okay, this is one function plus here also I can actually do the same thing. Okay, so it's 2. Sorry, right there should be a 2. There should be a 1. Original one. This is 1. So here what I can do is I can take out 2 common. So this will be 2, and then okay. So this is z. Z modulus of z is less than 2. So modulus of z by 2 is less than 1. Okay. So that means if I take out 2 common, I can simply write it down as 1 divided by z by 2 minus 2. And then I can just adjust it. Maybe I can take a minus sign here. Correct it first. If I take 2 common, I can take the minus sign out. So there it will be 1 minus z by the same thing, right? Now what I'll do, I'll simply expand this 1 minus z, 1 by z to the power minus 1, and this is 1 minus z by 2 to the power minus 1. Use this and expand it. That's it. Okay, expand it, you get your answer. That's it. So you have to just find out the region in which it is analytic and design the function in such a way, okay, so that you are not violating that particular condition. So here also it's the same. I know 1 by z would be less than 1. I know z by 2 would be less than 1. So in that way, I can actually design my function and do it. Okay. If we do the next one, okay, this is modulus of z greater than 2, right? So, okay. So if we do the next one, number 3, I'm not expanding any of them. Okay, I think we could do it. I will give you just one task to do. You'll do it once and then it will be clear. So this is greater than 2. Okay, but I need it to be less than 1. So, if I take modulus of z is greater than 2, that means 2 divided by modulus of z. If I take the reciprocal of this would be less than 1. I hope this is clear to all of you, right? If 3 is greater than 2, right? If I take the reciprocal of 3, that means 1 by 3, it will obviously be less than 2. So whenever I take a reciprocal of this, okay, 2 is not a problem. I can simply write it down as modulus of z divided by 2 is greater than 1, right? It's the same thing. And then if I take the reciprocal, it's obviously going to be less than 1. Okay, so just remember this simple idea. If 2 divided by modulus of z is less than 2, it obviously implies that 1 divided by modulus of z will also be less than 1. Because then, 1 gets divided by 2, you divide by 2 on both sides, okay? This is always going to be less than 1. Okay, that's obvious. So this is the condition that we are going to use here. That means here also we have to take out your z common. So if I just write down the function here, fz is equal to minus of z minus 1 plus 1 divided by z minus 2. This is z. I need it in terms of 1 by z, so I can just write it down as minus 1 by, I take z common. So if I take z common, this is nothing but 1 minus 1 by z. And 1 by z is less than 1. 1 by z is less than 1. Done for this. The second function also, maybe I can take z common here. So here I will have 1 minus 2 by. So depending on the condition, you have to decide what you have to take out of the term. You have to take out z, or you have to just take out the constant. That's important. So z I've taken it out here, z I've taken out here. So this is now defined. 1 by z is less than 1. This is 2 by z, this is also less than 1, this is also defined. Okay. The food for thought here is that you just think about it, try to sleep over it, you should be able to get your answer. And then simple, 1 by z, x की जगह लेंगे 1 by z, expand करेंगे, हो गया, is 1 divided by z, is 1 minus 2 by z, expand करेंगे, हो गया. Just expand it, simplify it, that's it, and get your answer.
Hello, sir.
Yeah,
Yeah, how we get 1 by mod z is less than 1? So can you please again repeat this line?
1 by mod of z is less than 1.
Yes, sir.
So let me just take this value here, okay. So maybe I can take this example here. This first time, yeah, okay. So this is there. So I'm taking that 3 is less than z. Also, maybe we can do this 3 by 2. Okay. So here it is mod of z is greater than 2. Let's say we say 3 is greater than 2. Okay. So that means 3 by 2, okay, would be or maybe देखो एग्जाम्पल एक्सट्रैक्ट करना पड़ेगा सही समझ जाने के लिए नहीं हो जाएगा या कंफ्यूज होते दिस एग्जाम्पल आई कैन टेक so 3 is greater than 2 that means 1 divided by 3 is going to be less than 2. Okay, so in general I can say that 1 by 6 is going to be less than 1, correct? Now you might have a term like 3 by 2, so that means this would be 3 by 2 is 1.5. This example I think it's not correct. To take a practical example and then I think I can able to show it. So this is mod of z greater than 2. So if I take 3 is greater than 2, so this would be 2 divided by 3 would be less than 1. Okay. So now look here. 3 is greater than 2. That means if I take 2 on this side and then take the reciprocal of this is going to be less than 1. So if you look into this, 2 divided by 3, this is definitely going to be less than 1, right? So this is less than 1. So it means that if 2 by 3 is less than 1, then 1 by 3 will also be less than 1. Does it make sense now? You got this now? Is it clear? See, 3 is greater than 2. That means 2 by 3 is less than 1. You can check the value, right? 20 by 3, 0 point so on 6 again. It will be less than 1. So if 2 by 3 is less than 1, 1 by 3 is definitely going to be less than 1. You getting it? Because you
Yes,
see,
sir.
you are basically what is happening is you are multiplying something at the numerator and you are saying less than 1. So that means if I just remove that numerator, whatever is being multiplied, I'm even reducing the value further. So that is definitely going to be less than 1. If 2 by z is less than 1, 1 by z is definitely going to be less than 1 because this is already multiplied in the numerator with a value. It is less than 1. But if I am removing the multiplication factor which is at the numerator, it is definitely going to be less than 1 again. Right? This for sure. So that is always going to happen. This is something which is more or less universal in nature, right? So that's how you are doing it. Okay. So you have to just remember these few things. You sometimes do miss out these things. Okay. So to just take this example, see, I thought this is very obvious. When I took examples, I fumbled, but then I realized, okay, I have to take this way. It will be more easy to make you understand. Okay, even if you don't, take this, you understand it from here itself. Numerator multiplying with a value, this is less than 1. I'm not multiplying with a value, that means I'm reducing the value further. So that is definitely going to be less than 1. Okay, anyway, so this is the fourth one, z plus 1, and this lies between 0 and so if I take this example here, we're going to use the same technique where we do a replacement. So here we are going to say z plus 1 is equal to t, okay, or z is equal to t minus 1. So that means whatever condition we are going to analyze is going to be on t. So that means the function ft is equal to minus of 1 divided by, this was z minus 1. So z minus 1 means t minus 1. So t minus 1 will be t minus 2. I can write it down as t minus 2, just doing it directly. Okay? 1 divided by, this is z minus 2. In place of z, I'll put t minus 1. So minus 1 minus 2 will be minus 3. So this will be t minus 3. So that means whatever limit we are going to put, we are going to put it on t. That means here t is going to be between 0 and 2. Right? So if you are looking into that circle of radius 1, that means I can say that modulus of t divided by 2 would be less than 1. So consider this part. Modulus of t is less than 2. That means modulus of t divided by 2 would be less than 1. That is one condition. And if modulus of t greater divided by 2 is less than 1, that means modulus of t divided by 3 will definitely be less than 1. Because this is the denominator is increasing to 3, that means the value will reduce further. So that is definitely going to be less than 1. Okay, so just try to think about it analytically. Why I'm taking 2 and 3? Because the singular points here are 2 and 3. That's why I'm taking it to be 2 and 3. So what I will do is I will just take this minus 1 and I make it to 1 divided by, I'm just going to take out 2 common now. So if I take out 2 common, I take 1 minus 3 by 2 minus 1 divided by, I will take out 3 common, so this will be 1 minus, right? And then this takes down. That's it. So it's more or less similar, okay? It's nothing new. We are doing the same thing, expansion. The all important formulas, 1 plus x expansion and 1 minus x to the power minus 1 expansion. If you remember that, you are going to do it very easily. You can leave it at any point, okay, when you expand it. It's not that you have to write it down in most simplified form. But it's a standard practice to combine all the t term, combine all the t square term, then simplify the coefficients, keep it there, and then leave it, okay. That will be the best practice. Don't leave it halfway, doesn't look good. important. In competitive exam also, where you're getting similar questions, you are going to do something like this, okay, where it will be in the simplest form. So that is expansion, okay. So you can, try all four of them. I'd suggest all four of them. You just understand the main logic here, and then just do the expansion. Expansion is normal algebra. I'm not going to explain it, but then just to make sure that you got it, let me just give you one problem here, and let's see if you can solve this. Okay, this is a mathematical technique that you have to use. Just use some logic. Okay, the function is z is equal to z square minus 4 divided by z plus 1 and z plus 4. When you get such function and if you are asked to expand it, you can easily expand it using the Taylor series idea. Not a problem. But then sometimes what happens is they will give you the conditions or the regions in which you have to expand it. In that particular point, you have to straight away know that you are basically doing a Laurents series expansion here. So this should be options are, this is modulus of z less than 1. That's the first question. The second part of the question would be modulus of z less than 4 less than 1. And the third part of the question is z. Okay, try doing this. It's slightly tricky. Think about it and try to do it. Okay, then only you'll find it easy. See, I'll give you a hint here. The problem here is that on top, it is basically a quadratic function. Z square minus 4. You have to try to write the equation in such a way that on the numerator, you are not going to get a quadratic function. And for that, definitely you have to take, expand this, take the LCM and divide it into two parts, okay, so that you are getting rid of that quadratic function. Explain this, how exactly to do it. You might already know it, but then, we tend to forget things. Does happen. If you have, let's say 3 and you are, let's say, 17 divided by 3 yesterday. So when you divide it, you just write it down 5 here, and then you say 15, and the remainder is 2. Okay? And if you just want to write it down, what you do is you write down 5, whatever is here, plus then you write down whatever is the remainder. So it's 5 into 15, so 17 by 3. So 17 by 3 is this way, and this way. Right? This is what you do. Here also it's the same. Okay, you take and then can you switch off your mic if someone's mic is on? Z square minus 4 and z plus 1, z plus 4. So if I expand this, it would be z square. Here will get into 4 and 1 into z, so this will be 5. And then it should be 1 into 4, so that's it. So we should get this, right? Here also we do the same thing. Okay, we can just take this to z square minus 4, and you know how to divide this. Z square, just divide it with 1. So if you divide it with 1, you will get z square here. And the remaining of 5z plus 4. So this is something, a division of algebraic function which you have done in linear class 8, 9, 10. Subtract one from the other, this gets cancelled. Minus 4 will become minus 8. So you get minus of 5z. So 5z minus 4 minus 4 minus 8, right? So if I use this technique idea, I can actually write down this as whatever is there, 1 question plus the remainder minus 5z minus 8 divided by the term by which I divided it. So that is z square plus 5. To recall these things, these are basics, okay? We all need to know this, remember this. So 1 minus I can take out, and I can take this with 5z minus 8. So I have reduced this entire term, and this I'll just go back to the original z plus 1, z plus You see, I'm using normal algebra, normal maths, and I've converted into form from where everything will become easy for me, right? Here also I can easily find out what is the value of A and Z, and if you remember in partial section, the same thing. It's A divided by Z plus 1. Okay, I'll just put the minus B divided by Z. Or to find out A and B, this time it's not 1 divided by right. To find out A and B, A would be nothing but this is there, so I cannot ignore this. 5Z minus 8 divided by Z plus 1, so I'll just take Z plus 4 here. And what will be the value of Z? You can take it from here. Z value is minus 1. I'll put plus 1. 5 into minus 1 is minus 5 minus 8. Yeah, oh sorry, is plus. So taken minus common here. Plus. Minus 5 plus 8 is 3. With the minus 1, yeah, minus 1 plus 4 is 3 and 3. So A. Similarly, you can do it for B, okay, and calculated B. Actually, that's it. You got it. Okay, this one will always be there when you expand the function. Just keep it aside. Take the value of A and B and expand it. Okay. So this is the way that you can do this. Okay. So it will, as time goes on and you tackle more and more numerical problems, you'll see there will be different forms.